Take a look at this website. So imagine you're in a hotel room and your room number is 111. You get your key card and you can enter your room. But imagine that same key card, you can access other rooms like 112, 113, 114 and so on, just by pressing the card against the door. So that's not supposed to happen. But in websites, that does happen sometimes. So let's say this website was a banking website where shows an account number in the URL. So in here we have an account number in the URL. And what we can try to do is just change that number. So that shouldn't enable us to view other accounts. Now we are viewing the account of Alice and it shows the balance and that's all it does. But by changing that number, we shouldn't be able to see accounts of other users. If you are able to do that, it's called insecure direct object reference, or basically looking into someone else's account or changing the numbers. It's called IDOR short, or insecure direct object reference. And so let's change that number. We can change it to 2. And now we have suddenly Bob's account with his balance. You can just try to mess around with websites and see if by just changing the URL, just by changing a number, you can access other account data. So of course this is not supposed to happen. So how does this happen? Many websites, they use numbers or codes in the links. So in this case, it uses a code for the specific user ID or account ID, in this case 3. And because it's programmed, and if there's no check, this can be changed. So for example, the 3 can be changed to 1, and suddenly we're in another account. Now, in this example, you're only viewing information. It's risky because this vulnerability is not just about viewing. Imagine you could change someone's information or maybe transfer information from one bank account to another. So it's not just about viewing this vulnerability. It can be have different consequences depending on what the web application is doing. So some websites do check, so they check if you're logged in and check some other information to see if you are allowed to request that information. So in this case, anybody can change the number and request the information. So, and then why do websites have this kind of flaw? So programmers are often on busy schedules and they don't always get the time to add the necessary security. And so sometimes they just take shortcuts or the easy way, thinking, okay, who's going to guess those codes anyway? Or maybe they're thinking, I want to be home by 5 p.m. So sometimes those security vulnerabilities just appear, or sometimes they can be overlooked. And so as a user, you always have to be cautious. You can put information into websites, but that doesn't necessarily mean that your information is secure. A vulnerability like this someone could potentially see your information or access your information and so on. So they might be able to get your personal data or do other things. Or as an attacker, you can potentially use information of other people or do actions that you're not supposed to do. So how can you think of this vulnerability or either vulnerability? You can think of it like a broken lock on a mailbox. So there's a lot of mailboxes and you can use your key to open any mailbox because the mailbox system is not secure. So you can sort of think of it like that. Hi, you can think of a website like a big folder or a big file cabinet. So normally you can only open the drawers or folders they let you. But that's not always the case. Sometimes with a little searching, you can open folders or drawers you're not supposed to. They call that directory traversal. So before you dive in, it's important to know the website's IP address, internet address, or home address on the internet. A simple way to get it is using the ping command. So if you open a terminal, you can type the ping command with any website. So let's say ping google.com, and it will return the IP address, the internet address of google.com. So any website on the internet is just a name, but the actual computers behind them have internet addresses or IP addresses. So in the case of google.com, this is its IP address. Now, that is very useful for when scanning a target computer. So on the internet, or in general, when you scan, you can use either the full name of the website, or you can use the IP address of the website. Let's go to the fun part. Any website might have files or folders that we're not supposed to access. So what you could try to do is to manually search for them. So going with a dictionary and then typing google.com/ for example, customers.db, or google.com/ readme.txt. But you can imagine doing that manually would take a lot of time and would get very boring. So you can do it in a more fun way. On Kali Linux, you can use a tool called DIRB or DIRBuster, and it's like a detective. It searches for hidden folders and hidden files inside a website. So what we can do is we open Kali Linux terminal, and then we type DIRB with your target. So in this case, I'm gonna use the target for an address on my local network, and then I specify -x. This means I'm looking for files of the type .db. And as it runs, it goes through a dictionary. You'll see here the file it's using, user share, DIRB, wordlist, common.txt, and it's simply trying all of them one by one, all of those links with .db at the end. So it's trying in that way to find out files that exist on the target computer that you're not supposed to access. So maybe we find hidden files. In this case, it's already found one, customers.db, and it will just continue scanning. Now you can do that for many file formats. So now we scanned for .db, but perhaps they have other files there as well. Maybe they have a zip file, so we can search for .zip, and it will do the same thing. It will scan the whole website. It will try to access every file, and if a file can be accessed, it will show that. So now it's scanning for zip files. So as DIRB runs, it will list out all files and folders that it finds. If a folder can be accessed or a file that is not meant to be public, bingo. So that is a vulnerability of the type directory traversal. And so in this case, we found a file called secret.zip as well. So you can imagine that scanning, you can find out a lot of information. So only scan websites you're allowed to. Imagine walking in someone's house and operating all the drawers without asking. That would be illegal. So it's the same thing here, depending on the country you're living in. But the principle works like that. So you can scan a certain file, .zip, .db, or whatever file format, or maybe just scan the website itself, and then it will look for folders on that website. So you'll see, using that word list, it is scanning. So this is the actual word list. So if you go to this directory, let me break the scanning. If you go to that directory, you'll see it's using common.txt. Now there are other word lists here. You'll see big.txt, which is larger. You also have a small word list and other languages. You can find some other word lists. And with DIRB, you don't necessarily have to use that word list. You can use other word lists as well. The more word lists you'll use, or the longer, the more probable that you find hidden files or folders. Now in this case, the common.txt is an English word list, so it would work with English websites. If you have another language website, you would need a word list for that specific language. So with DIRB, you can specify your custom word list as well. You see, if you type DIRB, there's all kind of flags you can use. specify the word list file, and you can specify also some other information. But that's the general idea. So for example, here it's using another word list. So with the specifies the website, and then it specifies another word list, more technical word list. But that's the general idea, to find hidden files and folders that are exposed but shouldn't be, and that might give you more information or possible valuable information, or even an option to hack the computer in its entirety. Imagine a giant bookshelf database where you keep the information. So many big websites, like online stores, they're popular. They want a big secure room to put all their information. It's called a database, and there are many database variants like MySQL, MariaDB. And why? Because many people want to look and buy the same books or the same products at the same time. So it's very good to have all that information stored. So, but smaller websites, so a small shop or a personal collection, they might just use a single file to keep track of everything. There's no need for a large room for storing all those products, and tedious to set up. So they might just go for a simple file to store the product information or such kind of information. But there is a problem. So imagine if you write a diary and you just place it in your home. Anybody who could visit your home can read it. So if your diary or flat file database is left in a place where website visitors can visit it or can find it, they can read and take everything. So it's really a big no for if your information is sensitive. So it's a bit like you leave your private diary at the coffee table for anybody who enters. Now, of course, you wouldn't do this in real life. However, this does happen for many websites. So a popular system for databases is called SQLite. So then you have a single file that stores all of the data. So you can think of SQLite like a system where you can add data, read data, update data, and delete data from a database. The same is true for the giant database systems like MariaDB or MySQL. They effectively have those functionality too. So with SQLite, all of the data is stored in a file. Now, what if the website visitors could access that file? Then suddenly they might be able to access all your data. So let's open a terminal here. So this is the website we are interested in, bank.local. And what we can do is try different words to see if there's a database file on that link. Now, you can try that manually. For example, you can say, try to see manually with different words to see if that exists. That would be very, very tedious. So what you can use instead, or what hackers use instead, is automated tools for that. So they will open a terminal and use a tool called Deerbuster or Deerb. So Deerb is all of those URLs automatically using a word list. So we can say Deerb with the website .local, and let's say in the static directory, and then we specify look for files with the extension of .db, database files. So that could be a possible extension they use, or .SQLite or .SQL. You can search for files. So what it does, it tries all of the files in a word list. In this case, the word list common.txt. So that's stored in user share Deerb word list common.txt. And you'll see here at the bottom is trying all those URLs. And for all of the words in the word list, it tried all of these. Also 4,600. Of course, if you have a larger word list, it's more likely that you find something. And in here we found a database file. So what we can do is copy that link and download it. So we can just paste it in, and now the database file has been downloaded to the computer. Of course, we were not supposed to access it, but because the database file was publicly exposed, you can just access it with a link in this case. And we found that using Deerbuster, we are then able to access it, and we can then look inside the database. So let's take a look at the file we just downloaded. So we can use the file command to see information on the database. You'll see it's a SQLite database. We can use the program SQLite 3 to into the database, or alternatively, you can use SQLite Browser, which is a graphical interface that lets you browse the database. Let's use SQLite 3. Now we can see tables. All of the data in databases is stored in tables. So you can think of a table of an Excel sheet or a simple spreadsheet. So we have one table here called customers. Now let's take a look at the data. So we can do that with the command select star or asterisk from customers. Now don't forget the semicolon on the end. Press enter, and you'll see now we can access the actual customer data of that bank. You'll see name and also a password. Now the password here is not stored in readable text. It's stored as a so-called cryptographic hash. So it's stored in a kind of coded way. It's called a password hash. Now many password hashes can be cracked. So you might think that, okay, just because it's stored like this, nobody can figure out the password. But there's many tools that you can use to gain access to the password. One of them being CrackStation. So you can go, let's copy this password, and we'll go to crackstation.net. We'll paste in the password and click the I'm not a robot option, crack hash, and then it converted that cryptographic or that password hash into the actual password. So now we know the password of that user. Now you can do that for any user. Sometimes the passwords can be cracked and sometimes not. It really depends on how secure password is. So unsecure passwords can often be cracked. This tool. For example, we can take the fourth password here of Andrew and try to crack that password. And you'll see we got that password as well. So now you would be able to log into the website, to the bank site, and use that username and password that you found earlier. So we have all this information. We can then log in as Andrew, we just got the password, or John, or we could try to crack the other password hashes. There's lots of websites on the internet. Let's take a look at this website. So imagine this joke website, like a comedy club with a robot comedian, where you tell the robot a name, or the website a name, and it cracks a joke using that name in the joke. So for example, we can add John, click submit, and now it tells a joke with the name inside the joke. And so that's all nice and fun. And of course, it's dynamic, so anybody can put a name here, and it tells a joke using that name. So there's many websites where you have a certain input box. So in this case, we have an input box here. And so many websites have one or more inputs or input boxes where you can type something and the website responds to that. Now, of course, the normal use is where you just type your text in there, in this case a name, the expected input. But what if you don't do that? What if you put a sneaky command in there, like John, turn off all the lights? So if the robot isn't careful or the website isn't careful, it does whatever it shouts at it, so it would turn off the light. So that is what command injection inside is like. So here we have a website that is just showing a single joke given a name. Type the name, it does the correct output. But what if instead you sneak a command in here? So instead of a name, we say a certain command. So let's do that. Let's try to put some command in here like date. Now you'll see I put a $sign and brackets around it. That's in programming language, that's a way to escape the normal text. And so let's click submit. and you'll see now it outputted a date inside the joke instead of a regular name. So we were able to run a command by escaping the text like this and then typing the command in between the brackets. Now this is a Linux command, so this system is running Linux and that's why it accepts Linux commands. There's all kind of Linux commands, so we now have control over the system. For example, let's say we run the command whoami to see our username, and you'll see it says we are root. On Linux systems, root is the administrator of the system. It has complete control over the system, so it can delete software, install software, change the configuration files, add new users, and so on. You have complete control over the system. We can do any kind of Linux command now just by typing the wrong input. So just by typing the escaped input with the command in between those braces. So you'll see here in this directory. And now we can do anything. We can create a new file. So this would create a new file called example.txt. The touch command does that. We run it. You'll see there's no output, but that file has now been created. So if we list the files in the current directory with the ls command, like this, you'll see the example.txt file has been created on the victim's computer, on the website's computer. And so by injecting commands, sometimes you can take over a computer and run any kind of command that you want. So programmers, they should filter the inputs and check if the input is correct. So in this case, only names are allowed, and the $sign, for example, shouldn't be allowed, because it's using the $sign with the braces. We can type any command. For example, we can see which users are logged in. Now, obviously, this is not the output that the programmer intended, but because we are allowed to use special characters, we can now run commands on the website's computer, and we can basically take over the whole computer now because we can run commands as administrator. You can also target a computer directly. So here we are running Kali Linux on a computer system that is made for hacking. So first thing we'll do, we'll open a terminal. It's this little window here. Here we can type the commands. And what we can do is to scan the target computer. So to scan the target website to see what is running on that website. Is it just the website, or is it perhaps something more? Maybe they have remote access or mail server or other things running on that computer. So we can scan using a tool called Nmap. So that's NMAP. Nmap. You'll see that if you run it, it outputs some text. And a lot of text. You'll see the version number of Nmap, and basically to use it is Nmap with the targets after that. So if you scroll down to the bottom, you'll see here Nmap with some commands. So here they're scanning a website. Let's do that. So let's copy this one just for example and paste it in. So let's scan that website, and you'll see has some open ports, so some applications are running on it. Port 80 is typically websites. 22 can be remote access, and then they have some other ports here. So using Nmap, you can see what applications are running on that computer besides possibly the website. Then we can use Nmap to scan a target computer. So what I'm going to do here is change it to my target computer. It can take a moment, and you'll see in this computer scanned, which is a computer on my local network. This is a local network address, but you can scan using this command. And in this case, you saw that the SSH is running on a Ubuntu Linux computer. So we can target that. We could simply try to connect. So let's just try to connect. Now it asks for a password. We could try to guess the password. And you'll see that it would take a lot of time. You can try password by password, but it would take ages to guess the password if we go through some list of possibly known websites. So instead of that, we can do it in an automated way. Now SSH, if you didn't know, it allows you for remote access to online level remote access. And we are trying SSH because that is one of the things that is open on the computer. You'll see SSH here, open SSH. That is the output of the nmap command. Now it's not always open. Some computers allow remote access. In that case, you can try to target it. Now, to crack the password, what we can do is use a tool called Hydra. So it's spelled like this, Hydra. We press enter. Again, it will output information about the command. So you'll see the version number and other information like that. Now on the bottom, you'll see an example of how to use it. So we can say Hydra, then the user. Let's say the user is Frank. Then we need a password list. So where do we get a password list? There's lots of password lists online where you can download millions of commonly used passwords, or even hundreds of millions. And Hydra would try every password one by one. Now, Kali Linux also comes with a password list included. So if we open the File Explorer, and instead of the Kali directory, we go to the user share word list directory. So that's user share word lists. You'll see a file called rocku.txt.gz. That is a password list file, but it's compressed. It's like zipped. So we need to extract it. I'm gonna copy this to the Kali directory. And now I'm gonna extract it. Right click, extract here. This is simply a word list, so a list of millions of passwords that is included by default on Kali Linux. So it's a list of passwords that are often chosen, and about 1 million of them. So if the password of that computer is in that list, it will find it. You'll see now we have a text file, rocku.txt. We just extracted this file, and it contained a text file of 133 megabytes. I'm not gonna open it because it would hang the computer. There's that many passwords. So I'm gonna specify here rocku.txt, which is a password list, and then the target. And what it will do is try one by one every password in that password list for the user I specified. Now, of course, you don't always know the user of your target computer, but perhaps you can guess it. Like if you check LinkedIn, which people are working in the company. So that's what hackers typically do. Also to find some information about the people working there, because that could lead to potential usernames. Now, of course, you can also specify a list of commonly used usernames. So if you do a capital L, you can specify a list of users as well. But let's go with this lowercase l. And then you have to specify a specific user. So we can try this one. And might take a moment. It will try every password one by one. And you see it already guessed the password. This was a really bad password. So now we have SSH access to this computer, this username and password. So now you could log into SSH and type the password, and you're inside the computer because SSH is remote access. So we just hacked the computer. We have the password. Now many Linux computers, or I should say all computers, have a root user. So if we use Hydra again, we can try the same thing for root. Root is the administrator of any Linux computer. So try the same thing, but now with root. And just scan it. Now, depending on the password, where the password is in the list, if at all, it can take a while to crack the password. Because it tries every password one by one, and it's about 1 million passwords in that file. So it could be if the password is in the bottom of that file, it's just gonna take a long time to crack the password. It might also be that the password is not inside the file, and then you would just wait and it would never come up. So it's important to have a very large file to increase your chance of success. So 1 million files in the rocku.txt is a possibility, But on the internet you can find even larger ones of 100 million or even bigger. And so the more passwords you have, the more likely you will find success with this kind of attack. Now this attack is called a brute force attack because it tries every password one by one. And RockYou.txt here contains like a million passwords, and it's just trying them one by one. So let me show you the first 30 passwords of that file. So it's just trying every password one by one. So it would try for the user root in this case, try root password 123456, 12345 password, and it will just go step by step through all these passwords. And the size is about 1.4 million passwords. Let me show you. With this command, you see 1.4 million passwords that it's trying. So of course it can take a while, this method, to hack a website or hack a computer, depending on where in the list that password is. Or even if it is in the list as well, because maybe this 1.4 million password list is not enough and you would need a bigger one.